Hey guys, welcome back. Today we'll be covering AP Calculus AB FRQ number 5, and this is from the 2019 exam. So we can see that we start with this graph right here, and it has a region R inside of it. And so it's enclosed by two functions, g of x and h of x, and the y-axis and the line x equals 2, even though it's kind of ambiguous. So let's get started. Part A is asking us to find the area of R. And so we know R is enclosed by these two functions. And I'm sure that you guys know that in order to find the area, we have to subtract one from another. But we need to know which one we have to subtract. And so if we look closely, we can see that g of x is equal to -2 plus 3 cosine pi over 2x. So this function, 3 cosine pi over 2x, can't be greater than 3, right? Because cosine of anything can't be greater than 1. So the max that this value can go to, if it was starting from the origin, would be 3. And so we see that the top function actually hits 4 and even goes to 6. So we know that the top function can't be the g of x function with cosine, so it has to be the h of x function. So to find the area, we need to integrate, and we know that it's going to go from 0 to 2, because those are the two boundaries specified. It's with respect to x. So now we need to know, what are we going to put in here? Well, we just talked about that. We know that h of x is on top, and g of x is on the bottom. So when we do this, we're going to get integral from 2 to 0 of 6 minus 2 times x minus 1 squared minus -2 plus 3 cosine pi over 2x dx, obviously. And so now what we have to do is integrate. So let's start here. So we know that this is going to be 6x minus, and since here we have x minus 1 to the power of 2, we know that we can do chain rule. I'm just going to simplify it. I'm going to do, and I'm going to integrate as if it was just x, because we know that when we do chain rule and du dx, we know that this derivative is just going to be 1, so it's going to be very simple. And if you don't believe me or you're confused as to why that works, I have other videos that will talk about chain rule, and you can check those out. So we have this top function integrated. Now we have to do the bottom function, so we can make this minus -2x plus 3 sine, because the integral of cosine is sine, pi over 2x, and since we have to do reverse chain rule, this is pi, this is poorly drawn pi over 2. And we're evaluating this from 2 to 0. So this will become 6 times 2 minus 2/3, because 2 minus 1 is just 1 cubed, plus 4 plus, so we know that sine pi over 2 times 2 will just be sine pi, which is just 0, minus 6 times 0 is 0, 2/3 times -1 cubed, minus 0 minus 0 plus, and if we do sine of 0, it's just 0. So we end up getting 12 minus 2/3 plus 4 minus, so these become positive, minus 2/3. So we're going to get 12 plus 4 is 16, minus 4/3. 16 times 3 is 48. 48 minus 4 is 44/3. And that's the area of R. Part B. Alright, so the region R is the base of a solid. For the solid, the cross-section perpendicular to the x-axis has the area A equals x plus 1 over x plus 3. And so we can just set this up as a simple integral. Area is equal to 1 over x plus 3, 0 to 2. The base is just a change in x, because we know that the area perpendicular, so if we look at this like it was standing up, so pretend this is the flat view, the area of the squares perpendicular to the base would be a equals 1 over x plus 3. And yeah, so if we find the total area, if we find the total volume, we need to integrate. So if we let, in this case, we know that this is very simple. It's just ln of x plus 3 from 2 to 0. We can do ln of 5 minus ln of 2. That's our answer. Part C. Write but do not evaluate an integral expression that gives the volume of the solid when r is rotated around the horizontal line y equals 6. Okay, well, this one is pretty simple, so we do the same two bounds, and now this time what we need to do is basically, if you look at a graph, this is the line that we're rotating against. This is the top function. This is the bottom function, poorly drawn, obviously. And so if we're trying to find the volume that's created, we're going to find the distance from here to all the way down minus the distance from here to here. And that tells you basically it gets rid of this empty space between the axis and the top function, and it ensures that the bottom function is carrying out the shape. So we can do 6 minus g of x as our big R squared minus 6 minus h of x as our little r squared dx, and that will give us the area. Oh, and obviously we need to multiply by pi, and yeah. Okay, so that's it for this FRQ. If there are any questions, let me know in the comments down below, and I'll try to answer them as quickly as possible. Thank you guys for watching, and be sure to like and subscribe if you want more content like this, and check out my other videos for more calculus help.